Atlantic Ocean 360 million years ago. Long before dinosaurs walked on land, before trees covered continents, something ruled Earth's oceans with absolute authority. A shadow passes through murky water, 33 feet long, weighing 4 tons, covered in armor plating 2 inches thick. Its jaws snap shut in 50 milliseconds, faster than you can blink. This was Dunkleosteus, the apex predator of the Devonian period. But it wasn't a shark, it wasn't a whale, it was an armored fish. And here's what makes it even more terrifying. Dunkleosteus didn't have teeth. Instead, its jawbones sharpened themselves into blade-like edges that worked like industrial shears. Bite force analysis from 2006 reveals 8,000 pounds per square inch. Stronger than Tyrannosaurus rex, stronger than modern crocodiles, stronger than any bite force recorded in nature today. One bite could cut through bone armor like scissors through cardboard. But fossil evidence from Ohio shows something paleontologists didn't expect. Dunkleosteus bones appear alongside regurgitated armor plates from other armored fish, meaning it ate heavily armored prey, then vomited up the indigestible parts like owls cough up pellets. This wasn't a scavenger picking off weak prey. This was a predator specifically designed to crack open the most heavily defended animals in Devonian oceans. And that changed everything about how marine food chains worked 360 million years ago. Because nothing in those oceans had armor thick enough to survive contact. Sharks existed during this time, primitive species with cartilage skeletons and basic teeth. They avoided Dunkleosteus completely. Fossil distributions show clear habitat separation, like prey species staying away from a predator too dangerous to risk encountering. Dunkleosteus reached 33 feet in length and weighed 4 tons, heavier than a modern pickup truck, longer than a city bus. Its head alone measured 6 feet from snout to gill plates, encased in armor plating that deflected attacks from every angle. The armor wasn't scales like modern fish. It was solid bone plates interlocking like medieval knight armor, with some sections measuring 2 inches thick. Stabbing through that armor would be like stabbing through a car door. But here's what made those jaws the deadliest weapon in Devonian oceans. The blade edges regenerated constantly through use. Modern sharks replace teeth when they fall out. Dunkleosteus jawbones wore down from biting, which kept them razor-sharp throughout its entire life. It was a self-sharpening weapon system that got more efficient with every kill. Compare that to modern predators with extreme bite force. Saltwater crocodiles generate 3,700 pounds per square inch. Great white sharks reach 4,000 pounds per square inch. Dunkleosteus delivered 8,000 pounds per square inch, double the force of a great white, concentrated on blade edges instead of pointed teeth. The difference matters because blades slice while teeth puncture. Dunkleosteus could shear through armored fish like bolt cutters through chain link, and the bite speed made defense impossible. Biomechanical studies published in 2006 by Philip Anderson at the University of Chicago used muscle attachment points on fossilized skulls to calculate jaw speed. The findings revealed a strike time of 50 milliseconds. That's 0.05 seconds from jaw opening to full closure. For comparison, human reaction time averages 250 milliseconds. By the time prey detected movement, the jaws had already closed. Modern mantis shrimp hold the record for fastest strike among marine animals at 23 milliseconds, but they're 6 inches long. Dunkleosteus was 33 feet long with a 6-foot skull, delivering that speed at massive scale. Running wasn't an option when facing something this large and this fast. Fossil evidence from the Cleveland Shale in Ohio, one of the richest Devonian fossil sites in the world, shows Dunkleosteus lived in coastal waters and open oceans. That's a habitat range covering thousands of square miles. Modern great whites patrol similar territories, but they avoid heavily armored prey. Dunkleosteus specifically hunted the most dangerous prey available: other placoderms, armored fish with bone plates and defensive spines. And here's what the fossil record reveals about feeding behavior. Dunkleosteus bite marks appear on armored fish fossils showing clean cuts through bone plates. Not crushing damage like crocodiles produce, but surgical slicing like industrial cutting tools. Some prey fossils show multiple bite marks from different angles, suggesting Dunkleosteus bit, repositioned, then bit again to fully breach the armor. Modern orcas use similar tactics on great white sharks: bite the pectoral fin, flip them over, then attack the vulnerable underside. But orcas hunt in packs. Dunkleosteus hunted alone. The killing method was pure mechanical advantage. Those blade-like jaws created a scissor action rather than a crushing action. Crushing damage requires massive force distributed across a surface area. That's why crocodiles need to shake prey and perform death rolls. Slicing damage requires force concentrated on a thin edge. That's why swords and axes work. Dunkleosteus combined 8,000 psi of force with blade edges thinner than a knife, creating shearing force no armor could withstand. Then there's the armor that made Dunkleosteus nearly invulnerable to retaliation. The head and anterior body were covered in articulated bone plates that moved with the body while maintaining complete protection. Modern armored fish like sturgeon have scattered bony plates. Dunkleosteus had full coverage from snout to mid-body, with plates 2 inches thick in some areas. Fossilized specimens from Morocco and Poland show these plates could stop bites from other placoderms and primitive sharks. Attack damage healed into the bone, meaning Dunkleosteus survived multiple encounters with other large predators. But here's what makes the armor even more effective: it was hydrodynamic. Modern armored animals sacrifice speed for protection. Armadillos move slowly. Turtles swim inefficiently. Dunkleosteus plates were shaped and positioned to reduce drag while swimming. Water flow analysis conducted in 2013 using 3D printed models in flow tanks revealed that despite weighing 4 tons, Dunkleosteus could reach burst speeds of 15 to 20 miles per hour. That's faster than most armored prey could escape, which meant the armor didn't slow it down enough to matter. And then there's the feeding mechanism that proves intelligence beyond simple ambush predation. Fossil sites in Belgium, discovered in 2008, contain dense concentrations of regurgitated armor plates, bone fragments from placoderms, scales from primitive sharks, shell material from ammonites. These fossil pellets appear in the same locations where Dunkleosteus fossils are found, suggesting feeding grounds where it repeatedly returned to hunt and digest. Modern sharks don't regurgitate indigestible parts. They pass them through their digestive systems. Dunkleosteus actively expelled armor plates after extracting meat, which is behavior seen in predatory birds, not fish. That's not instinct. That's learned efficiency in processing heavily armored prey. The reality is even more brutal than solo hunting capability. Fossil evidence suggests Dunkleosteus occasionally engaged in cannibalism. Juvenile Dunkleosteus fossils show bite marks matching adult Dunkleosteus jaw dimensions. In ecosystems where the apex predator will eat its own young, prey species have no safe refuge at any life stage. Modern sharks occasionally practice cannibalism in the womb before birth, but adults typically don't hunt juveniles. Dunkleosteus made no such distinction. But here's what separates Dunkleosteus from other armored fish during the Devonian. The jaw articulation allowed it to open its mouth wider than its head at rest, a hinged mechanism that created suction while generating bite force. Modern fish use suction feeding or bite force, rarely both simultaneously. Dunkleosteus used suction to pull prey toward the jaws, then closed with 8,000 pounds per square inch of shearing force. Prey couldn't swim backwards fast enough to escape the suction, and once inside the bite radius, escape was impossible. And the fossils tell one more disturbing story about effectiveness. Dunkleosteus lived for 50 to 60 million years across the late Devonian period without significant anatomical changes. When a predator design remains unchanged for that long, it means evolution couldn't improve it. The combination of armor, bite force, jaw speed, and size had already reached optimization. Nothing worked better than the existing design. Then a 2006 study revealed exactly how powerful Dunkleosteus jaws actually were compared to every other predator in history. Researchers at the University of Chicago, led by Philip Anderson, used finite element analysis, computer modeling that calculates stress and force distribution in complex structures, to reconstruct bite mechanics from fossilized skulls. They measured muscle attachment points, jaw joint dimensions, and lever-arm ratios to estimate force generation. Previous studies had suggested strong bite force, but lacked the computational power for accurate calculations. The findings shocked the paleontology community. 8,000 pounds per square inch concentrated on blade edges. That exceeds Tyrannosaurus rex at 7,800 pounds per square inch. It doubles saltwater crocodiles at 3,700 pounds per square inch and 4 times stronger than African lions. And here's what makes it more devastating. Those blade edges concentrated all that force into a cutting surface thinner than modern kitchen knives. T-Rex had conical teeth designed to puncture and crush. Dunkleosteus had industrial shears designed to slice. But the study revealed something even more significant about how those jaws worked. The jaw closing mechanism used a 4-bar linkage system, the same mechanical principle used in industrial crushers and cutting tools. This created a scissors effect, where force multiplied as the jaws closed. At the beginning of a bite, the jaws moved relatively slowly with moderate force. At the moment of contact with prey, speed and force both peaked simultaneously. Modern engineering uses this principle in bolt cutters and hydraulic shears because it's the most efficient cutting mechanism possible. And then there's what the jaw anatomy revealed about feeding versatility. Dunkleosteus could perform precision bites on small prey or devastating crushing bites on large armored fish. The jaw articulation allowed fine motor control despite the massive size, similar to how humans can grip a pen or crush a can with the same hand. That versatility meant it could feed on everything from 6-inch fish to 10-foot armored placoderms, giving it access to every food source in its ecosystem. The 2006 study also calculated jaw closing speed using muscle fiber length and attachment angles, 50 milliseconds from fully open to fully closed. That's 20 bites per second theoretical maximum, though actual hunting probably used single devastating strikes. The speed came from optimal muscle arrangement and leverage, not from large muscles. Evolution had refined the jaw mechanism over millions of years to achieve maximum speed and force with minimal energy expenditure. But the dominance period tells you everything about why Dunkleosteus became the apex predator of Devonian oceans. Dunkleosteus lived from 382 to 358 million years ago, a 24 million year reign at the top of marine food chains worldwide. For comparison, Megalodon dominated for 20 million years. Tyrannosaurus rex lasted 2 million years. Dunkleosteus outlasted them all while facing some of the most heavily armored prey species that ever evolved. The Devonian period is called the Age of Fishes because fish diversity exploded during this time, and Dunkleosteus ate the most dangerous ones, and the fossil record shows exactly why nothing could compete with it. Other placoderms, armored fish, existed during this period, some reaching 20 feet in length with thick bone plates and defensive spines. But none developed the bite force to breach each other's armor except Dunkleosteus. It was the only predator that could crack the evolutionary arms race between armor and weaponry. While prey species kept developing thicker plates and sharper spines, Dunkleosteus already had the solution: blade-like jaws that sliced through any armor thickness. Talk about an evolutionary dead end for defensive strategies. And then there's what happened to marine ecosystems after Dunkleosteus went extinct. The late Devonian extinction event 358 million years ago killed 75% of all species on Earth, one of the Big Five mass extinctions. Placoderms disappeared completely and never returned. Modern fish with lighter skeletons and more efficient jaws took over marine environments. The heavily armored body plan that defined Devonian oceans never evolved again because it was too specialized, too energy-intensive. But here's the critical point. Dunkleosteus didn't go extinct because something outcompeted it. It went extinct because the entire ocean ecosystem collapsed from climate change and oxygen depletion. When oxygen levels in oceans dropped below critical thresholds, large predators requiring massive energy died first. Dunkleosteus needed enormous amounts of food to sustain its 4-ton body and maintain that armor. When prey populations crashed, it had nothing to eat. The comparison to modern apex predators makes the dominance clear. Great white sharks hunt for 24 million years and counting, but they avoid heavily armored prey and get injured by seals occasionally. Dunkleosteus faced prey covered in 2-inch bone plates and never lost a fight based on fossil evidence. No healed wounds from failed attacks. No signs of starvation from prey scarcity. Just 24 million years of perfect predation until the environment itself collapsed. Dunkleosteus, 33 feet of armored fish with jaws that bit through bone like scissors. 8,000 pounds of force delivered in 50 milliseconds. Self-sharpening blade edges that got sharper with every kill. 2-inch armor plating that stopped every attack. For 24 million years before dinosaurs existed, nothing in Earth's oceans was safe. That's the reality of Devonian seas. The apex predator wasn't a shark. It was an armored fish with industrial shears for jaws.